Hi everyone and hello, welcome to this video. So last time we left off basically with our triangle, and then we had to find this data in a shader, and for this time I just want to move this data to a vertex buffer or a buffer in order to prepare it for the GPU. Now I was thinking like doing this and then input assembly pasting it to GPU in one video, but it turned out to be too long, so I scratched that idea. And now we're just going to prepare vertex buffer, and then next time we're going to use it. So idea for today is just get this to a vertex buffer object. So there are a couple of buffer types, like constant buffer, index buffer. The vertex buffer, as its name says, it runs per vertex, same that we had here, right? It will run for this vertex, and this vertex, so 3 times. And the buffer here just being some chunk of memory that can be passed to GPU, and let's define it actually. So we can start just by adding a new filter here, which is going to be called buffers. Then we can create a new buffer, and I'm going to call this vertex buffer. We're going to have multiple buffer types. For now, just one is enough. Then we can create a new filter as well here, which is actually, since we're going to be working with templates, we're going to need to just use one file. And then let's go here, and we're going to make a template out of this. Why template? Well, because we can have different types of data here, right? Usually it's going to be floats, but we can structure our data such that it's a struct, right, which might have position, color, texture codes, etc. So different types of structs can be used here. Then what we're going to need, we're going to have public. One of the things that we're going to have is constructor. We need to include our renderer. Include our renderer. That's good. So we're going to need that, and it can be just renderer reference to it. And we're going to have there's a private as well. Okay. Good. Then we're going to need a vector, which is going to be our data. So vector of any data. Says the vector, the data, and as a final parameter, what I wanna actually have is a string, which is going to be the bug name or label. Like if you work with some other APIs, it's called label. Here it's the bug name, and any object, this component object, I think can have this. I know for sure DirectX can have it, and what this allows you is kind of like to see the bug name on your resource when you GPU debugging, and we're going to see that a bit later on. So let's start with our buffer, which we're going to create here. It's just going to be pointer to the 11 buffer, and we can just call it buffer. Now, in order to create it, from our render, we're going to need device. So let's actually save device here because we might need it in future, right? When we decide to, for example, maybe update buffer or stuff like that. So our device is render get device. We get it from our renderer, and then device itself will have some method which is called create buffer, of course, which takes a couple of parameters. One is buffer description, which is description of a buffer. So you here describe, is it a constant buffer, is it a vertex buffer, is it a index buffer, stuff like that. Sub-resource data, it's just we pass data to it. That's our data resource, and then the final parameter is out buffer, right? Because so this will be our buffer here. And then as always, there is h result. So first of all, I mentioned that we're going to have this buffer descriptor, buffer and there are a number of parameters on it. If we take a look at its definition, we can say that we have byte width, usage, bind flag, CPU access flag, these flags, miscellaneous flags, I guess, and structured bytes, right? And you can see description for each one of them if you just search for the TD11 buffer description structure. And documentation here is quite good. One important flag for us for now is going to be usage. And under usage, we can see we have default usage, which means that a resource, when you pass this usage, it means this resource needs like write access by both CPU and the GPU. Then we have immutable. Resource can be only read by GPU, so we're going to use that one. And what all of this does is kind of optimizes it a bit better. So whenever you can, we use more restrictive usage essentially. Then we have bind flags. And here we define how our buffer is going to be used. We're going to use it as a vertex buffer. We're going to use index buffer in the future, constant buffer in the future. Maybe render target, but that's not related to a buffer. Some of these are just like bind flags for some other types of objects, such as, for example, textures or frame buffers. Anyway, I don't know. Then we have CPU access flag. This one we might not even need it, so it's just access read write. So it says here CPUs can change its contents and CPU can read its contents. Very important, like I mentioned. Try to keep these buffers like restrictive as possible. When you need something, then you define it. So don't use this, you might have some performance issues, you might do some weird stuff. Try to avoid it. So we're going to set everything to 0 unless there is something that's a bit more restrictive than a default. For example, for the usage, we're going to use immutable. Then we have these flags as well. Some of these are not even relevant for buffer, so we're not going to spend time here with it. And then you can read it. We're not going to use this for now, maybe in the future. Anyway, I just wanted to make you aware that documentation is really good here and you should use it. So let's get started. So buffer description, this should already set everything to 0. So we're just going to need usage, and I mentioned that we're going to use immutable usage. Then byte width. So byte width, I haven't mentioned it there, but it is a width of our data, right? So we take our data size and multiply it by the size of our data type, and that's it. Byte flags, we need to set it, and the rest of them can remain as is because they're not relevant here. In the future, we might use them for something else. Right now, not relevant at all. Then we can just paste it here, buffer descriptor. Be mindful it needs to be pointer, and I should probably zoom in because it's very hard to see. Then the second parameter was subresource data, initial data. So only really relevant property here for us is, well, pointer to our data, right, from our vector. There are two more parameters, pitch and slice pitch. And this is kind of used if your data, you're not passing the whole data, then you have to navigate it a bit, right? If you have offsets or you just want a chunk of memory, not the whole memory. So for us, we just want to take everything and that's it. So we need to pass that in init data. Once again, we're passing it as a pointer. And then the final parameter is our buffer, which is just pointer to a buffer. Or buff, yeah, pointer to buffer, let's try it like that. It works. So we just want to handle result. And we're not using errors, which actually use IO stream. Let's just say fail to create a vertex buffer, and that's more than enough. We don't care about the H result for now. And if the bug name is not null, So what we want to do is like your comp pointer objects should have this set private data, and then you can set some data on it. One of the data types is this debug object name, which is very weird and hard to read here. So that's one of the data types, and then this is wrong suggestion here, so let me just fix that. Set private data. First of all, we need data size and then the pointer to data, and this will just set the debug name, and then we can see in the GPU debugger this debug name. And I believe that's it. Actually, we can try to create it and see if we can use it. So if we go to our game, if we include Vertex buffer right over here, then we're going to need math library as well. And with Windows, DirectX math library is available, so we're going to use it. And then what I want to do is where we had our shader, I just want to use this. And XM float tree. So this is vector tree of DirectX, and then we can say vertices here. And let me just check this real quickly, because our right vertex was actually in the middle, so we're going to use it like that. And previously we used float 2, now we're going just to switch to float 3, because in the next video we're going to actually be working with these positions as a float 3 rather than, and then you can see values here. This is top vertex 0, 0.50, 0.5 minus 0.50 for the right vertex, and then we have left vertex as well with minus 0.5, minus 0.5 and 0. And then let's try to create a vertex buffer. So type is our example 3. And we just need to define, actually, let's define it as a vector here instead of an array. That's my mistake. Good. And then we can pass vertices here. And we're done. So if I try to run now, everything should be fine. Of course it isn't. So let's see here what went wrong. It's complaining about this because I renamed it wrongly. So that's one thing. Render references must be initialized, of course, because it's a reference. We cannot use it like this. We have to set it up like this. Almost there. Okay, it complains about this thing. So it just means that we need to add a library for it, because it's in a different library. Then in our game, right over here, we're just going to need a new one. And it's something DirectX GUID. I think this is correct one. So DirectX GUID. I guess it stands for that. I'm not quite sure. And then it works properly. Let's try to debug it. I'm just going to use an Nsight debugger, and I'm going to leave a link in the description of the video for some of the debuggers that you can use, because you can use Visual Studio debugger. You can use, I believe it's called Pix, which is DirectX specific debugger. You can use RenderDoc, Nsight Graphics, AMD has its own tool, Intel has its own tools, or for Intel I believe they allow only DirectX 12. Anyway, let's debug it. Here you just have like to specify your executable, which is going to be your project, and then x64 debug, I guess, and then we can just fire it up. We can try to catch frame. Of course, it doesn't allow Steam. it doesn't allow us to spy, I guess, on other games. We can try to capture the frame. And then here I already had a resource window open, but if I just go here, and then if we go to frame debugger, all resources, and then you can see our resources that are used. One of those resources is triangle vertices, and this should correspond to the name right over here, right? When we paste it to our vertex buffer, and then we used this, and this gives us this debug name. So that's why I included it, so that I can easily identify it here. If you don't have it, it's probably going to be named buffer and then one similar to this one. And if you just try to take a look at this, so this is our data. Of course, this doesn't mean too much to us. So we can just change the type of our data to show us float tree. And now you can see these are our vertices. So top vertex, right, 0, 0.50, then we have right vertex, 0.5 minus 0.50, etc. So all good. Just a note, like most of the debuggers actually require buffer to be used in order to in order to see it with NVIDIA Nsight. We don't have to do that, so that's why I use this one. Finally, now that we have that, we're almost close to being done, because like I mentioned, I don't want to use it. This video is going to be too long, so next time we're actually going to make use of it. But I did want to make another kind of type. So let's just create our vertices. And here we're going to have this different kind of vertex objects. And for example, here we might have position color vertex. So you're going to see what I mean by this. So we can just include, we need here DirectX11. Oh, come on. And then let's make it actually a struct. So by default, everything can be public. And I guess this is all right. So we're going to have position and then a color, right? And the color is float 4. Just be mindful of that. The full constructor, and then the constructor takes the parameters in. That's all fine. So in our DirectX game, what I want to do is just include it. So it was called position color vertex. And I just need to move it over here to vertices, and we don't need actually the CPP file. And then we can change this to position color vertex. So I need to modify this slightly. What I'm going to do is here, and then start typing everything at once. So we can have 0.0f, 0.0f, and then 1.0f. And then we need the comma as well, not on the last one. I think this should be fine. And then let's just change it to be slightly different colors. And here I'm missing one other bracket, which is array bracket or no. I'm kind of wondering what is it complaining about. Ah, of course. We actually do miss it. No, it's good. What this means is just that our buffer is going to be looking a bit differently. So something about the render is off. Let's try to build it. Maybe it's just Visual Studio acting weirdly. Aha, of course, I need to change the type here as well. So the reason why I wanted to do this is I just wanted to have a different buffer time. Okay, I need to exit here, and then we can, I should have just built it, but okay. And then let's try it here. I'm just going to capture frame. Then I get my frame. Once again, we need to go to our resources. We can find our buffer. Then we're going to configure it here. So you can already see that our buffer is way bigger. So we're just going to say float 3 and float 4. And as you can see, this corresponds exactly to our vertex, right? So here we have red color now, we have blue color, and this is still, sorry, this is green color and this is green color, but we're going to change it to blue. Anyway, you see how that works. So in a nutshell, this is how you create a buffer, right? You just need, basically, let's go over it. In our vertex buffer, you just need to call create buffer, and then you need to describe it. So here it can be vertex buffer, constant, different kinds of buffers. There are some additional properties. We haven't used them. We might use them in future or for some other objects. But right now the relevance are this. So we just need to say, okay, how are we going to use it? We can say we're not going to change its data we're saying here we're not going to change it at all. Like when we define it, it's like that. We cannot update it. For the future, we might have some that we want to update. Then byte width is just size of our data in bytes, right? Bind flags, we want to use it as a vertex buffer, and then we just paste initial data in, and that's kind of it. And then after you create it, you can set this debug object name. So there is last thing that I want to do is just like move this to this class, which we're going to call buffer util. Kind of same that we did with shader util. So I just want to do that. I'm just going to copy this because I'm lazy. And then in our vertex buffer, it's going to be almost exactly the same as here, just a bit different. So I'm just going to copy parameters because I don't want to type this. Let's go to our buffer util. Then we need using namespace, of course. For those comp pointers, we're going to have public. It's going to be static comp pointer, right? Have one buffer. Doesn't see it because we need 11 here. Another reason why it doesn't see it because I mistyped it. And we can say create vertex buffer. We can paste those parameters in. I'm just going to break them into a couple of lines. So we still need vector here, and then this is not going to be render. It's going to be pointer device. It's going to be our device, and of course it needs to be template because our data is going to be template, and then we can just copy this and we're done. Where are you? Buffer util, it's right over here. We can return buffer here. We just need to define it yet. Buffer, and here we return now pointer. Something went wrong. So let's try to use it. Buffer util, sorry. And good. Let's try to run it now. If it doesn't fail, then we're good. It kind of failed because here I forgot one more namespace, which is file stream. Okay, good. So that's it regarding this video. In the next video, we're going to try to make use of this buffer. Like I mentioned, it's just, I tried to do everything at once. It was too long, doesn't make sense. So I'll try to get next video already out next week. Yeah, so yeah, if you enjoyed this video, please like, subscribe, leave a comment, and until next time.